Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. I'm very delighted to see you once again. We are still treating calculus, okay? So we have the integral calculus and we have the differential calculus, okay? So today we are going to dive into another sector, okay? So today we are going to consider how to find the derivatives or how to differentiate inverse trigonometry functions. Remember, we've already set the ball rolling where we learned how to differentiate the normal trigonometry function. But this time around, let's look out for the inverse of trigonometry functions. So we said that when you have dx of sine inverse of, let's say, x, w, v, or what have you, okay? Let's say u this way. Now, when you take the derivative of this sine function, okay, so sine inverse of u, it gives you, that's u prime all over square root of 1 minus u squared. And remember that when you have a function of, say, f is equal to, let's say you have y is equal to f of x. When I find the derivative of y with respect to x, I have dy over dx is equal to f prime of what? Of x. So you would ask, or you'll be wondering, what does this prime mean? Someone would say u complement. That isn't the case. This is not what? A complement. It means what? Differential. We are taking what? The derivatives. So when you take the derivative of the function, it becomes what? F prime of x. Do you get it that way? So that is simply the meaning of u prime. Viewers, if you want to learn how to prove this, I have proved the formula for finding the derivative of inverse function, that's sine inverse. I've also proved the derivative for cos inverse, and I've also proved the derivative of tan inverse. Everything is well explained. So just go to my playlist, you click on calculus, then you scroll down, you will see proofs of inverse trigonometry functions, as simple as that. So having done this, so let us consider the following. So find the derivative with respect to x. You have, let's say you have sine inverse of, let's say you have x to the power 7 this way. So how do you find the derivative of this with respect to x? So viewers, what are you supposed to do? See here, we had u. So what did you do? We differentiated u to get what? U prime. So we have to also differentiate x to the power 7. Is that also? So we can say that, so solution. Let's see how to work out for this. So I have sine inverse of x to the power 7, right? But we know that the derivative of sine inverse of u is equal to what? U prime over square root of 1 minus u squared. So you will say, look, this is u and this is x what? To the power 7. So you can therefore say that let this u be equal to what? X to the power 7. So I'll say let u be equal to x to the power what? 7. As simple as that. So when you differentiate u, you will get what? You get u prime. So I find the derivative of u, you get u prime, which is equal to, we use the power rule of differentiation to work out for this. So what does the power rule state? It says that 7 times 1 there's 1 here, right? So 1 times 7, you get 7. Then you have x to the power. Then you subtract 1 from the exponent. So I have 7 minus 1. So therefore, u prime is equal to 7x to the power what? To the power positive what? 6. As simple as that. So we are going to substitute this into the formula. So therefore, we can say that the derivative of the sine, the sine inverse of u is equal to, remember we said it's u prime over 1 minus this, right? So by substitution, what is our u prime? Our u prime here, you have it to be what? U prime is equal to 7x to the power what? 6. So I'll just substitute. So I have 7x to the power 6. Then all over the square root of the expression. 1 minus. Do I know u squared? Yes, I know u. What is u again? We already know that from the question here. Be very careful. This is u prime, but we want what? We want u. So we said, let u equal to what? X to the power what? 7. So you write, so that's x to the power what? 7. Because remember, we said u is equal to x to the power 7, and u prime is equal to 7x to the power 6. So whenever you see u prime, you put 7x to the power 6, which has been, we've done it over here perfectly. Then you have here 1 minus, then u squared, right? So this is your u, right? X to the power 7. But because we are squaring the u, what do? You also what? You square this u. You get that? So you can say that when I square this u, this becomes what? U what? Squared. As simple as that. So therefore, finally, we are getting 7x to the power 6, then all over square root of the expression 1 minus. So using the law of indices, this exponent multiplies this exponent. So 7 by 2 gives what? 14. As simple as that. Viewers, this is the solution to the question d over dx of sine inverse of what? Of x to the power 7. As simple as that. Viewers, this is the end of the tutorials to the derivative or differentiation of the sine inverse functions. Okay, stay safe, stay blessed, keep following where I bring you the subsequent topic under derivative of inverse trigonometry functions. But this time around, we are going to look out for the cos inverse. Bye.